Right. So today we are going to last time, I think that last Tuesday, right? We were discussing about software engineering and we were discussing the designing and modeling. Actually, modeling is main task in designing. So today we are going to finish that part. Right. So I just have to finish the design and implementation because I went through the slides in system modeling and architectural design. So this one will be discussed, but I just want to go through your UCSC slides. Okay. So let's quickly go through. Anyway, we last time discussed the designing. Designing is all about modeling the solution or come up with different solutions and modeling and think about the alternatives, picking the best solution, etc. And we discussed that model, the designing involve the high level design and the, this is your note, I think. Okay, right. So the high level designs and the low level design. And also the high level design is the architecture and then the detailed design. And also when we are designing, we have to come up with the solutions, we have to model the solutions, we have to evaluate and pick the best solution. So then only we develop that. Okay. And there are different aspects of designing: the UI designing, program designing, database designing, interface, system interface designing, right? So many aspects are there. We can tackle those things separately as well. Okay, right. So we discussed these things last time. Okay, and also we can subdivide design into two: the logical design and physical design. So logical design is you design at conceptual level, at the theoretical level, and physical design means we modify or we adapt that logical design to a particular technology. For example, if you are using Java, we have to convert that concept into Java related concepts. If you are going to C#, we have to convert those into the concepts or the technologies supported by C# or .NET. Okay, so that is physical design. Okay, right. So let's and also we discussed last time some popular architectures. Okay, the 3-tier, the client server, peer-to-peer. Okay, then we discussed the layered architecture, repository architecture. Okay, so let's quickly go through our set of slides now. The design and implementation. I don't know why they have divided this like these three topics, right? So architectural design, system modeling, architectural design, and design implementation. Pretty much these three topics are pretty much they are talking the same thing in different ways. And a little bit, I really prefer if they had the architectural design first. That is how I explain. Of course, it's okay to do the system modeling, but system modeling we discuss. Right. So now we are moving to the designing and implementation aspect. Okay. But we have covered pretty much these things in the other aspects as well. Right. Right. So this is based both design and implementation. So therefore, we don't have separate topic called implementation. Okay. So when it comes to implementation, okay. So when it comes to implementation, we have to think about both. So there are some options. Okay, either we can build or we can buy it. So that is something we all know. If you decide to build, again we have two options. That is, you build or we build it in-house, or we outsource it. But very rarely now the software is built in-house. Very rarely. Almost 100% we outsource it to a professional software development organization. Okay, right. So again, the design process, it depends. We discussed this last time, whether we go for structured designing or object-oriented designing. It depends. If it is structured designing, we have to do some modular designs, whereas in object-oriented designing, we have to do using object-oriented concepts like class diagrams, sequence diagrams, how the classes are related, then how the messages are passed. So those things are there. We have to consider when it comes to object-oriented design. Okay. So if it is structured designing, do they mention about the structured designing? Right, not much. So they are pretty much interested in the object oriented. First, I will just briefly explain you the structured designing. What are the things we do? Then I will come back to the object oriented in a little bit more detail. Okay. So structured designing is if you are planning to develop the software in a structured manner, which is very, very rare unless you are developing a very small software. Okay. But anyway, it's one option, structured. But most of the projects, final year projects are unfortunately structured. Okay, structured. They use the structured approach. Unfortunately, very few number of students do the software, develop the software using object-oriented way. Okay, so the main reason is unfortunately again they don't understand. They haven't understood the object-oriented concept properly, and they don't have the guts. They don't have the courage to do their final year project using object-oriented concepts. Unfortunately, okay. So therefore, I would say more than 75% of the students decide, okay, we will go with structured approach. Okay. And only about 25% of the student use object-oriented concepts, so 100% object-oriented way. But when it comes to industry, it is other way, right? More than 75% or more than 80-90%, it's object-oriented software, and maybe less than 20 or 25% is structured. Okay. So that is also something you have to keep in mind. That is why we have more emphasis on object-oriented designing than the structured designing. Okay. Right. So when it comes to structured designing, so last time we discussed when it comes to the requirement analysis. Right. So remember we have the analysis and design. And in the last year's of paper also, they have asked about these object UML diagrams. Okay, so I just today I uploaded all the past papers, and also I uploaded the reference books as well. And this is software engineering subject was in level 2, so they took it to the level 1 for last year. So you have officially only 2020 paper, but you can refer the level 2 software engineering papers because the syllabus is pretty much the same, only slight changes are there. So therefore you can refer to the semester 3 past papers which I have uploaded to the Google Classroom. Okay, I have collected all those things into one PDF so that you just have to work with one PDF file. Okay, right. So we last time we discussed when it comes to structured analysis, we remember structured means process plus data approach. Right? Process plus data approach. So there in the analysis we go for the process part. Right? Process part again it's process and data, we subdivide. For the process part we go for context diagram. Right? Diagram to get the big picture, and then the data flow diagrams. Those are the two main diagrams. Okay, data flow diagrams to give you more details about how the data is flow between different data sources, sub-processors, etc. In the data part, we draw the business ER diagram. Okay, there is the ER diagram like this. Right? So a lot of students don't know what is the difference between this ER and the design ER. So when we ask them to send us your design the ER, they send this. I don't know. It's unfortunate. So this is your analysis ER. So this is your process modeling, context diagram, and data flow diagram. Okay. Now when it comes to designing, we can subdivide it into process and data because there is a structured, the thinking behind structured approach. Remember the concept of information is also we process data into information. Okay, right. So when it comes to I first take the data, you come up with the final, you normalize ER diagram. Right? Normalize ER diagram. You have identified your primary keys, foreign keys, okay, and those kind of things. So that is your data part, designing main designing artifact or the detailed designing artifact for the data. So when it comes to process, the main thing is your component or the modular diagrams. So we call it modular decompositions. Okay, modular decomposition. So you can subdivide into modules, say order functionality, payment functionality, right? The inventory functionality, etc. Then you can subdivide, say payment, maybe something like cash payment, uh, check payments, etc. Maybe orders, the general needs, the normal orders and express orders or whatever. It depends on your system. Okay. So likewise, you subdivide it. Subdivide it. So these are your modules. So this approach is called divide and conquer or modular decomposition. We discussed this when we were doing the programming subject as well. Okay. Before start doing the methods. So this is the main tool that we use to tackle the complexity. Okay, the modular decomposition diagram. Okay, modular decomposition diagram. Or you can give whatever the name, something related to that. And there are two main concepts when it comes to identifying these modules. So the two main concepts are cohesion and coupling. I'm just giving you an overview. Okay, then I will get back to your slides. Cohesion and coupling. So the idea is have high cohesion, right? Your modules must be highly cohesive and there must be low coupling. Okay. So cohesion means, if your cohesion means something like sticking together, stick aleno, right? Cohesion කියන්නේ ඒකයි. සමහරු ඉන්නේ husband wife ට හොඳටම ඇලිලා ඉන්නේ හැමතිස්සෙම. හරි? අපි girlfriend boyfriend හැමතිස්සෙම ඇලිලා ඉන්නේ. සමහරු එහෙම නැහැ. ඒගොල්ලෝ එහෙම ඇලිලා නැහැ. එතකොට දැන් එහෙම ගොඩක් ඇලිලා ඉන්නකොට අපි කියන මුන් දෙන්නවල දැන් බන්දලා දෙන්නවා. මුන් දෙන්න මෙහෙම කරන්න බෑ. මුන් දෙන්න මේ එකට ඇලිලාමයි ඉන්නේ. දැන් මේක බන්දලා දීලා එක ගෙදරක නවත්තන්නවා. So same thing. So if your module has highly cohesive things, right? So that is good. Right? That is good. නැත්නම් එක ගෙදරකට ගිහලා කියන දෙන්න කතා බහ කරන්න ඕනේ නැති ඉඳලා හරියන්නේ නැහැ. So same thing, if you take a module, it must be cohesive. So cohesive means that module has highly related things, right? Related things. So that is what is my cohesion. So your modules must have a cohesive functionalities. That means these functionalities are sticking together. They are highly related. Right? They are highly related. Okay. So high cohesion is preferred when you decompose. And then we have a concept called coupling. So coupling means to which extent one module will communicate with another module. Right? If this module is frequently communicating with this one, so we say there's a high coupling. Okay, high coupling. But if that communication is low, that means there's a low coupling. Okay, there's a low coupling. So in structured designing, we prefer high cohesion and low coupling. Right? So usually when the cohesion is high, the coupling is low. Okay, so coupling means you have to get some services, you have to communicate with the other module. So if you have to frequently communicate with another module, maybe something that is more relevant to your module is in the other module. So maybe there is a mistake you have made in your design. Okay. So therefore, if you have high cohesive modules, typically the coupling will be less. So we can't make it zero coupling. Of course, your software is interrelated. So therefore, the coupling is a natural thing, but excessive coupling is bad. So therefore, in structured programming, in modular decomposition, we always prefer high cohesion and low coupling. And these two goes hands in hands. Naturally, when cohesion is high, coupling will be less. And naturally, when coupling is high, that means your cohesion is less. Okay. Right. So any questions? So I'm doing very fast now. Right. So that is the main concept behind the process aspect, the detailed designing of process we subdivide it into modules and submodules, and we make sure that our modules are highly cohesive and relatively low coupling. Okay, and of course the data part, we have to do the normalization. We have to identify primary keys, foreign keys, and we have to map the associative entities into tables, connecting tables, etc. That we are covering in a separate subject called database. So therefore, we don't have to discuss it in detail here. Okay, so that is just an overview of how the structured designing happening. Okay, structured designing, because your syllabus they have now earlier you have subject called system analysis and design, and semester 2 and semester 3 you had the object oriented system analysis and design and software engineering. But in your new syllabus that you are following, they have removed the system analysis and design. So actually the system analysis and design subject used to cover these things. So they have sort of a completely removed this, the structured aspect. So they have just touching those in the software engineering subject. So that is why they have taken software engineering subject here. Okay. But you have the object-oriented system analysis and design in your semester 3. Okay. So, right. So therefore, I am just filling a small gap, because otherwise you miss this, because they have removed the SAD subject without taking that to a properly taking that to a software engineering subject. Okay, I don't know why that happened, but anyway, I just did it, because otherwise there's a hole in your software development subject of understanding. You can't just understand only object oriented, because I told you that even the 75% of the students develop their software with structured approach. So then you must know the structured approach. Okay, right. So now we are moving to the object-oriented designing concepts, right? So I think one of you last time also in the chat asked, can you explain a little bit of object-oriented concepts? I told you that we will be doing it a little bit later, right? So today we are going to little bit more detail. We are going into details, but anyway, we went great detail during our programming topic. Right? We spent whole, I think, 2 or 3 whole sessions discussing these object-oriented concepts, and not only that, implementing those things using Java. Okay, so therefore these things are not at all new to you, right? So object-oriented design. In object-oriented design, so here you have the process plus data, we separate it, but in object-oriented we don't separate it into process and data. What we do is we just think in terms of objects. That is why we call it object-oriented, right? So in object-oriented designing, we just think in terms of objects. Okay, we think in terms of objects. So if someone asks what are the basics of object orientation, so we can think of it like that: object-oriented basics, the object-oriented concepts, and some advanced concepts. So what are the basics? The concept of object and message. That's it. Object and the concept of message. So there's a special case of object, or not a special case, something related to the concept of object, which is a class. Object and class are 2 different things. Okay. So I hope you know the difference between object and class. Okay. So can someone tell me what is the difference between object and class? Kata තියෙන කෙනෙක් ඉන්නවා නම් සමාජයේ බය නැතුව මූණ දෙන කෙනෙක් ඉන්නවා නම්, what is the difference between object and class? ඉන්ටර්විව් එකට ගියොත් අනිවාර්යෙන් මම ඉන්ටර්විව් එකේ ඉන්නවා නම් බෝඩ් එකේ ඉන්නවා නම් මම අහන අනිවාර්ය ප්‍රශ්නයක් තමයි ඕක. කටපාඩම් කරුවේ හාල් පාරුවෙද්ද ඔළුවක් තියෙන කෙනෙක් දිහා ගන්න. Can someone explain? Say you go for interview. Now in the interview, one of the person who is in the interview board asks what is the difference between object and class, because we are developing software in object-oriented way. So therefore we need someone who knows object-oriented concepts. Otherwise, so what is your answer? What is your answer? Anyone? No one, right? So fine. Right. No one has the answer, right? So now you can see that unfortunately, right, large number of students developing the software using structured way. So that is the reality. Right. So the difference between object and class is, so when it comes to object-oriented analysis and design, we look at the system as set of objects. Anyway, we have discussed these things. Okay. We look at this. We look at or we understand the system as set of objects interacting with each other, communication and collaborating with each other. Right. So that object can be account object, payment object, right, order object, customer object, right? So we discuss in detail. So that is not a, that is a message. So we have these objects, and these objects are communicating and collaborating with each other. We call it messaging. So this is messaging. So that is how you look at the object-oriented. That is how you look at system in object-oriented way. Okay. So we have set of objects. They communicate and collaborate with each other by passing messages. So then what is a class? So now we have so many objects, so many payment objects. If you take a bank, thousands and thousands of account objects, thousands of customers. So there are different objects, right? There are different types of objects, customer object, payment object, right? Loan object, and so much, so many. Okay, so many type of objects are there. So we can't model and represent each and every object in the designing level and in the programming level as well. So therefore, in order to represent all the account objects, we create a account class. To represent all the payment objects, we create a payment class. Right? So that is the, so simple answer is object is anything that we are interested in our system. Class, so there can be different objects like that, thousands of objects communicating and collaborating with each other. To represent all the objects of same type, we model a class. Right? We model a class, and through that class, we can create objects when we are using an object-oriented programming language like Java, C#. That is why we have the new keyword to create objects, right? New account, new payment. Okay. Right. So if you don't understand object-oriented concepts, or if you don't have the confidence in developing software using object-oriented concepts, right? Don't ever think of going for the software development field as a software developer, okay? Because you are completely lost. Right. So those are the basics: the concept of object, concept of message, and the concept of class. Okay. So then the next level of concepts are abstraction, encapsulation, inheritance, and polymorphism that we have discussed. Okay, this is not new thing. Polymorphism, abstraction, encapsulation, inheritance, and polymorphism. So those are the next level concepts. So what is abstraction? Abstraction means, I told you that last time also, some people can handle abstraction. Some people, they like to stay with the concrete concepts because they don't have the capacity to go into the abstract level. So abstract means we only look at the minimum essential things, right? Especially when it comes to designing, we only model the minimum essential, which is relevant to us, our system that we are going to develop. Okay, so that is called abstraction. It's a concept. It's a concept that, or it's a value that we appreciate and we use when it comes to design. Because when you don't, when we look at only the minimum essential, our life is much more easier, right? Otherwise, so many unnecessary things we have to look at. So it's waste our time. So the second concept is encapsulation. So encapsulation means you put it into structures. So encapsulation, right? So to make it noun, you have this. So capsule, you know what is a capsule list, right? Capsule is karalak. So you put it into a structure, right? Put it into a structure. බෙහෙත් කුරු ටික අර capsule එක ඇතුළට දැම්මට පස්සේ යාට දැන් structure එකක් තියෙනවා. බඩට යවාක. හරි. Right. So encapsulation means when it comes to those classes, we want to put it into a structure. So in a class diagram, we just draw like this. So we need a structure to discuss that, okay? Because these are conceptual things. So class is an encapsulated concept. So it has encapsulated the attributes and behaviors. Attributes of the customer and the behavior of the customer. Attributes of the account and the behavior of the account. So we put it into a together, we call it, say, account class. So these are very simple concepts. Of course, they are very serious concepts, but very simple concepts. Okay, encapsulation. So then we have the inheritance. So inheritance means we can create hierarchy of classes. Hierarchy of classes, so that the classes below the hierarchy get some attributes and behaviors from the classes above the hierarchy. Not only from this one, even from this one, this class inherit. Okay, so that is called inheritance. So inheritance promote reusable code. Reusable code, because if you have code it in the general class, your specific class automatically get those attributes and behaviors. You just have to code the special things on, which greatly increase the productivity, maintainability of a software. Okay, right. And finally, we have the polymorphism. So polymorphism means, so there are two definitions. We discuss both the definition, not only we define it, we went to the coding level and demonstrate how the polymorphism is working and how it is going to help us to create reusable code. So polymorphism, one way of looking at polymorphism is ability of an object to act in many forms. Right? So if you take object, it can take many forms. Say this is shape, maybe it can take the circular form, maybe rectangular form, maybe parallelogram form. So if an object can take many forms, we say that is polymorphism. So polymorphism means polymorphism, many forms. Many forms. So this word, I think from the Greek word, many forms. Okay. So then someone will ask, what is big thing about ability of an object to take many forms, right? So can someone explain it? Why polymorphism is important? Why do we like to have object to take many forms? So the idea is, when we need this kind of a form, we can send this guy, because this guy can take that form. When we need this kind of a functionality of object, we can send this guy. So that again, right? So this is not I am explaining polymorphism. Polymorphism was explained in semester 1. So this is I'm just refreshing. Okay. So now it again facilitate reusability, code reusability. And if you have not understood it properly, you have to ask questions, right? It is your task. My task is not to make you understand. Right? My task is help you understand. If you, at the end, if you don't understand it, it is your issue. It is not my issue. Okay. At the end, if you have not understood it, that concept, it is not my issue. It is not my fault. It is your fault. Okay. Very clearly. Right. So therefore, you have the opportunity to, if something is not very clear, you have the opportunity to clarify it, ask questions, and can you repeat it? Can you explain it? Can you give me a different example? Because at the end, you must understand the concept. You are not attending a class to not to understand a concept. You are not doing a degree and collecting concept that you don't understand. So that is a failure, right? That is a failure. So that is, you are wasting your time. So at the end of each and every subject, at the end of each day, you must have some things, more and more things that you understand, not more and more things that you don't understand. Okay, so you must collect things that you understand, not things that you don't understand. And don't go somewhere and say that I am doing a very advanced subject, I am doing a very advanced degree, I don't understand anything about it, so therefore I am very proud of it, right? So I am very proud of it. I mean, you are a stupid, right? You are a stupid. That's all. Right? Because this is formal science. Formal science concepts are 100% understandable things. Okay, 100%. I told you that in the very first day. Okay, so therefore, if you don't understand anything, you have to keep asking questions. Keep asking questions. Keep asking questions from yourself, with your friends, with maybe someone like me who is explaining those things. And at the end of the day, you must have another set of concept that you have understood. Right? Next day, another set of things. So that is where you are getting more and more happy. Your confidence is high, right? So all the good things are happening to you. Otherwise, you are sad. I don't know. Usually, if you don't understand something, a person might be sad, right? And also your confidence is getting low and low because you know that I have found another thing I don't understand, and blah blah blah, right? And you can't go to an interview. So many issues, and so many issues. It's a chain reaction. Okay, right. So any questions? Imagine we design a phone. Yes. So phone has certain functionalities, right? Phone has certain functionalities. First, we have to abstract it. So first we have to abstract it and understand what kind of a thing we want to do, right? So if it now you know that there are different type of phones. Assume that we are just designing a simple phone, right? Nothing else, not a smartphone. Smartphone is actually a mini computer. Okay, so there's nothing called smartphones there, though we just call it phones because our phone happen to be this smartphone. Smartphone is a small computer. So therefore, forget about the smartphone. So then our question should have been how to design a computer, right? So let's think of a traditional telephone. So then you have to first abstract it. Abstract it. So you have to ask, uh, what is a phone? So phone is a voice communication. So remote voice communication device. Let's forget about even SMS for the time being. So the very traditional phone. So it's a remote voice communication device. So then what are the functionalities we expect? Of course, we must be able to convert our voice into some sort of signal and send it to the other side. And in the other side, that signal must be converted back to audio signal. So this is audio. And my telephone must convert that audio signal into some sort of a electromagnetic signal, something like, or maybe radio wave if it's a mobile phone. Okay, some sort of electromagnetic signal, not that audio or voice signal. Then it must be transmitted, and that is not part of the telephone. So that is part of the communication infrastructure. Your task is convert the audio signal into the compatible electromagnetic signal. And when the other guy talk, your phone must be able to convert that electromagnetic signal back to a audio signal. Okay, so that's it. If you look at a telephone, there's the very traditional telephone. That is the only requirement. That is only requirement. So you look at it like this way. Telephone is a device where audio signal can be converted to electromagnetic signal, and incoming electromagnetic signal can be converted back to audio. Okay. So is that all? Now, can someone tell me? Now I try to understand the telephone as abstract concept, right? The very traditional, old-fashioned telephone. Okay. Right. Can someone tell me, is it full or do we need anything else? Can someone tell me? Now, is that abstract view enough or do we have to add anything else? So this is now you have to think like a serious designer. You don't have to think anything rubbish, unnecessary things. At the same time, you must not, you must cover everything as well, right? If you miss anything, so that means you are in again trouble. Okay. Can someone tell me? Think of a traditional telephone. Uh, so is this good enough, or do we have to add anything, or is it more than enough? Now, I told you that so the professionals, we need a lot of responsibilities, right? So they can't do half of the stuff, right? වාට කියන්නේ බෑනේ මාර සීන් එක ඔපරේෂන් එක කරලා ඉවරනාට පස්සේ ડોක්ටර්ට කියන්න බෑනේ මාර සීන් එක මට ඒක මිස් වුණා කියලා දැන් ආයෙ කපන්නද නේද? So you must do a full thing at the same time, you must not do unnecessary things. නේද? ඒකනේ ડોක්ටර් කෙනෙක් වුණාම අපි ඒ තුනක් අරගෙන සමානට මදි කියන්නේ නේද? එයා එච්චර precise වෙන්න. Anything else? Nothing. Okay. So what about dialing a number? මේ ෆෝන් එකේ කතා කරන්නේ කොහොමද? ඔයාලට කතා කර ඉන්නවා. ෆෝන් එකේ කතා කරන්නේ කොහොමද? ඒ කියන්නේ ඔයා නිකන් මේක අරගෙන මේ ජාතිය මතනවා කතා කරනවද? So your phone must have a way to dial. Right? So because you want to talk to different people. So there must be another requirement is how to dial a number. Right? How to dial a number. So that you have to think about it. So you can't miss it. And also when a new call comes, how it notifies you. And notify incoming calls. So you can't forget about that. Otherwise your phone is not going to useful, right? It's useless. Right? Useless. So therefore, when you are abstracting, it doesn't mean that you are get rid of or you are just forgetting things, but you just take the essential concepts for your concern, because then you have to design those things. Okay, so now you know that you have to way to dial numbers, you need to have a way to notify incoming calls, and also your audio, there must be a way to, there's a requirement converting your audio signal into electromagnetic signal and backwards. Okay, so that is a minimum for a very simple phone. If any of these things are missing, it's not going to work, right? It's not going to fulfill. Okay, right? So those are additional things. Okay, so those are additional things. I'm just asking you the functionalities, right? Functionalities, those are non-functional things, right? So my question is, think about the essential functionalities. Okay, right? So that is abstraction. That is abstraction. Okay. So when you're designing also, you have to have abstract view of how this is done. How this is done. How this is done. Okay. So that is abstraction. Then encapsulation. So encapsulation is you put it into structures, right? For physical things, encapsulation is not very big thing, but anyway, that is important, right? For example, now if you take something like computer, it has encapsulated certain things into certain components. The monitor, right? So then you have the hard disk, the memory chip, the processor. So that is good. So processor is separate thing, memory chips are separated, monitor is separated, keyboard and mouse is separated. That is really good. Okay. Even the graphic processor, we can even separate it out. Sound card, right? The network card. So that is, you are encapsulating those functionalities into separate component. So that is encapsulation. So that is why computer is a very smart design. But if you take something like your old television, your radio, it is not like that. It's a one monster. We call it monolithic, right? One big electronic circuit, right? It's ugly, right? So very poorly designed device. Obvious, radio and televisions were designed before computers were designed. So at that time, the engineers never had that serious concept of encapsulation, abstractions, because the human knowledge is also evolving. Okay, but unlike your radio and television, your computer is really well thought out, uh, abstracted as well as conceptual, encapsulated thing when it comes to hardware. Okay, so similarly, your telephone also, and we may be able to do a little bit of encapsulation. Maybe the receiver is taken as one component, so that even when the receiver has issues, you can just replace it. Okay, so things like that we can do. Okay, maybe the the speaker or the dial part we can design separately. So there likewise there are some encapsulation options. So then the inheritance, right? Then the inheritance. So of course in the telephones we can think of the general telephone. Then you can think of some telephones with some additional functionalities, right? So maybe a telephone with maybe speakerphone also, something like that. Or maybe later we can think of this telephone must support not only taking calls, it must support sending SMS as well. So then you need to have small display unit, right? So then you have to modify your keys so that not only numbers, now you have the alphabetical characters. So that is sort of a polymorphism also. Now your telephone can act like a telephone as well as texting device. Now you can see it's multiple inheritance, right? Your telephone is a telephone. Your telephone can take the form of a telephone as well as it can take the form of a SMS or the texting device. I don't know whether you have heard it. In 1980s, we had the telephone separately, and we had a device called pagers, text pagers. Right? I don't know whether you have heard it. Maybe your parents, you just ask from them, they will say people used to have text pages. So that is only doing SMS messaging, right? Only doing SMS messaging. You can send SMSs and you can receive SMSs. So later what they did is they combine the telephone and SMS messages together. So that is polymorphism, right? Your telephone can take now act like a telephone as well as now it can act like a text page as well. Okay, right. So I hope you got some idea about it. Okay, so how these object-oriented concepts are. It's not only for software development, right? It's not only for software development. It is applicable to right, a lot of areas, and that is why our modern designs are much more sophisticated, maintainable, reusable things. Okay, so these concepts are everywhere. These concepts are everywhere, right? So those are the object-oriented concepts. So then we have some advanced concepts. So that is where you have the concept like design patterns, right? Design patterns, some architectural patterns, and some advanced concepts like inversion of control, right? So you will be learning those concepts in your level 2, right? So advanced concepts, right? So some of those include design patterns, MVC pattern, okay, adapter pattern, decorator pattern, observer pattern. So many design patterns are there. Okay, so many design patterns are there. Let me see whether they are mentioning about the design patterns in your note. Let's see whether they are mentioning about design patterns. At least mention. You can see architectural patterns such as spy and serve pattern. Right, weather station is component of, right. So this is another pattern, observer pattern. You can see design patterns are there, right? So design patterns are there. So those are advanced things. So you have to look at the big picture first, right? So you have the basics of object orientation, things like the objects, messages, then the concepts, abstraction, encapsulation, inheritance, and polymorphism. Then we have the advanced things. So design concepts, design patterns. Okay. So there's another concept called inversion of control. which is heavily used in enterprise development. Inversion of control. So there's another. So here you have a. There's another way of explaining this. We call it Hollywood principle. Right? Hollywood principle. So Hollywood principle is another name for inversion of control. Inversion means what? You make it upside down. We make the control upside down. Right? Make the control upside down. Now remember, now the way you used to be in your school, traditional schools is your teachers control you. Right? Your teacher, class teachers control you. So that is why there are so many regulations, right? You have to come at 7:30, you can't speak, you can't talk. So why? They control you. They control you. So, but what we expect is as citizens, right? It was a it was make a transfer. So then government control you. Teacher වෙනුවට මොකද කරන්නේ? ධාර්මික government teacher නේ. ඊට පස්සේ ඔන්න government control you. උඹලා අපි කියනවා තමයි වගා කරන්න ඕන, අපි කියනවා තමයි කන්න ඕන, මේ දවස්වල පරිප්පු කන්න බෑ, මේ දවස්වල හරි, මේ දවස්වල පිටි බොන්න ඕන අපි කියන જાතිය. හරි. අපි කියන වෙලාවට තමයි light දෙන්නේ. So that is you are under control. The majority is under control of someone, right? Maybe parents control you, teachers control you, the government control. So what is inversion of control? Inversion of control means we make it upside down. We make it upside down. So now you control the teachers. You control the citizens, control the government. Citizens control the government. Then government එකවම අහවල් පිටණීට වරෙල්ල ගිහලා ඔක්කොමල ගාලා කඩාගෙන ගිහලා පිටණී ඉන්නවා නේද? ගාලා කඩාගෙන ගිහලා අර දේශපාලක වෙනකොට හුරි ජය වේවා කිය කී ඉන්නවා. So who control? The government control the citizens. So inversion of control means citizens control the government. Citizens lage pressure එක දානකොට government එකේ ඇමතිලා ඉල්ලාස් වෙනවා. Citizens ලා. හරි? ඒගොල්ලන්ට ඕනි විදිහට ප්‍රතිපත්ති හදාගන්න. So that is inversion of control. So in software development, inversion control means again the same thing. So rather than A controls B, okay, so if B can injected to A, B can be injected to A, so that is called inversion of control principle. Okay, so that is advanced concept that you will be learning in your semester, in your level 2. Okay, say so in software engineering, inversion of, I'm just referring to the wiki page. In software engineering, of course, we are doing software engineering subject now. Inversion of control is a programming principle. We call it IOC. IOC inverts the flow of control as compared to traditional control flow. In IOC, custom written portions of computer program receives the flow of control from generic framework. A software architecture, of course, we are now talking about the architecture and design. With the design inverts control as compared to traditional procedural programming. In traditional programming, the custom code that expresses the purpose of the program calls into the reusable libraries to take care of the generic tasks. But with inversion of control, it is the framework that calls into the custom or task specific code. So traditionally, we call the framework. In inversion of control, the framework calls you. So that is why we say it's upside down. So those concepts anyway you will be learning, because that is why we take it to the advanced concepts. Okay, so you are still in your level 1. So gradually you will be learning those things. But if you want to understand these things, first of all, you have to understand these basics. Okay, so if you don't understand what is object, what is messaging, what is class, what is inheritance, what is polymorphism, what is encapsulation, what is abstraction, so you are not going to understand these advanced concepts at all. Okay, right. So this is just to give you the idea that, so this is how the object-oriented software is designed, architectured, and developed. Okay, right. So, right. So that is the at high level how the object-oriented software is designed. I told you again. I will again explain it. I just mentioned it. The object-oriented basics, the concept of object, the concept of class, and the concept of messaging. Right. So there are some diagrams we show how these classes are interrelated. That is called class diagram. So then we have another UML diagram called sequence diagram and communication diagram. So that is all about how these objects pass messages to get these things done. So that is where you learn sequence diagrams, communication diagrams. Okay. Right. So then the concepts, the abstraction, encapsulation, inheritance, and polymorphism. And finally, the advanced concepts like design patterns, inversion of controls. Right. So there are a few more which we will learn in later. Okay. Right. Now we are moving to your slides. Okay. Now we are moving to your slides. Now, once you understand the concept, you must be able to understand your slides. Okay. Right. So let's move on to your slides again. Design and implementation. So software design and implementation is a stage in the software engineering process which executable software system is developed. So that is actually not the designing, that is where the implementation or the development is. Okay, so this implementation is overloaded word. So therefore sometimes you will get confused as well. So here when they refer to implementation, so they refer to development. Okay, but in a lot of books, they will call it design and development, and they will refer to implementation as deployment. Okay, so therefore it's different people use the different terminology, but here but when they mean implementation, actually what they have mean is development. Okay, right. So software design and implementation activities are invariably interleaved. Yes, so it's bit of designing and developing. Right. So while you are developing, you can refine your design. So therefore, they are highly related because what you design is what you develop. Right. So therefore, they are highly related. When you are designing, you have to think about, is it feasible to develop like that? Is it easy to develop like that? And then also when you're developing, you have to make sure that you develop according to the design. So therefore, they are interleaved. Okay. And also, your design process involve a little bit of creativity as well, because you are designing new thing, right? You are designing a new software. So this creativity is not like the visual art, so right, music or whatever like that. So this creativity is different sort of a creativity. It's a creativity in problem solving. So you need to have some creativity in order to solve problems, right? So that we are talking about that kind of a logical creativity. Okay. Right. Implementation is the process of realizing the design as a program. So implementation or the development is realizing means make it reality. Right. Your design is abstract concept. It's a model of the solution. The development is making it a reality or create your software. Right. Your software is the realistic solution. That development is making this concept, right, model into working product. Okay. Right. So I explain you the build and buy. Right. So why we prefer object-oriented approach? Because when you develop in object-oriented way, it's more reusable, more maintainable, right? And it's more natural as well in designing and development. Okay. Right. So these are very high-level things they are discussing. Okay. How the look at the overall context. Okay. A big picture as set of components. We discussed the architectural design last time. Okay. The client server, repository, layered architecture, Okay, we discussed those things. So this is just example they have given, right? For the weather, that they have taken sort of a weather station as a sort of a example, and for that they have come up with a sort of a modular package diagram. Okay, right. So this is one package. You can look at it as the sub packages. Okay. So I explain you the connection between object and class. Okay, object is that individual thing, right? But the class represent set of same or similar objects. To represent all the accounts, we have the account class. To represent all the customers, we have the customer class. Okay. Right. So now they are trying to understand, identify the classes for the weather station application. Okay. So the weather station itself, weather data, right? Some measurement instruments, etc. So then when it comes to class or object, your object or class has attributes and behaviors. Remember we discussed that attributes and behaviors. So because it's encapsulate, class encapsulate both attributes and behaviors into one entity, one unit. Okay. So these are pretty much attributes, and these are pretty much behaviors, and some more behaviors. Okay, I don't know how they have done it. I think it looks like this is your first part, this is your last part. I think these two diagrams, because these are the attributes, then these are the methods, and these are the rest of the methods. Okay, මම හිතන්නේ මෙතන දෙපැත්ත මාර්ක් කරලා දාලා තියෙනවා. කැලේ දාලා තියෙනවා. And I told you that we are interested in how these classes are related. So that is called class diagram. Let's see whether we have class diagram somewhere. Unfortunately, no class diagram. Okay. Right. So I will explain it separately because your note is not explaining it well. Right. So when it comes to this, now you have first you have to identify your objects, or in other words, the classes, and how these objects are messaging or communicating. Okay. So, and also then how these objects are related, right? So the relationships can be either inherited. For example, your savings account is inherited from your account. Remember we called that last in this programming subject in semester 1, inherit. So these relationships can be inheritance, or it can be association. So your programming note has all those things. How to code this also, how to code inheritance, how to code association. Association means one object can call behaviors of the other object. So then we say association. Association කියන්නේ ඒක නේද? A සහ B අතර association එකක් තියෙනවා නම් තමයි ඔයාලට දැන් අපේ ඕගොල්ලෝ ගෙදරයි අල්ලපු ගෙදර අතර association එකක් තියෙනවා නම් ඔයාලට මොකක් හරි වුණාම ඔයාලට ගිහලා මොනවා හරි ඉල්ලගෙන එන්න පුළුවන්. නැත්නම් කියන්න පුළුවන්. ඒ association එකක් තියෙනවා. දෙකට association එක කියන්නේ ආශ්‍රය. එහෙම association එකක් නැත්නම් ඔයාලට ඒ behaviors call කරන්න බෑ. ඒගොල්ලෝ ගණන් ගන්නවා. So same thing. So association means we say that class A is associated with class B. When if A and B are associated, A can call behaviors of B. Or it depends on the direction also. In association, we have one unidirectional, A to B or B to A, or it can be bidirectional. I told you that in designing, bidirectional is not represented as two arrows, rather no arrow means bidirectional. Right? One single arrow means it is in that direction. Right? It is in that. So here A can call the behaviors of B, but B cannot call the behaviors of A. So because this is unidirectional. If it is something like this, now B can call the behaviors of A, but A cannot call the behaviors of B. But here bidirectional, A can call the behaviors of B and B can call the behaviors of A. Okay, so that is association. So then we have two more concepts like composition and aggregation. They are whole part, right? Whole part. So that is this. These are consisting of these objects, something like that. Right? Diamond shape we use. Right? For example, hospital is consist of wards. University consists of faculties. So to represent that, we use this particular notation, diamond notation, and this is the parent, this is the child. Okay. So likewise, we are interested in seeing how these classes are interrelated. So we call it class diagram. Right? We call it class diagram. Right? So if you do a Google search, say class diagram. Anyway, you have all those things in your semester 3 object-oriented SAD. Okay. So if you take something like that, you can see this is inheritance. Let me open it. So this is inheritance and this is association. So this is unidirectional association. This is bidirectional association. And this is composition. Right? Your order consists of odd items. Okay. So likewise, so this is called class diagram, another UML diagram. It shows how the classes are related. How the classes are related. Okay. So unfortunately, your node doesn't have class diagram. Okay. So that is why, because class diagram is the mother. So everything, the first what we want to look at is the class diagram of a system. So that is how the classes are related with each other. Classes in the sense, in a way, it's objects as well. Okay. So then we are interested in how these objects communicate with each other when it is doing some tasks, right? Say, for example, you are doing a money transfer in your e-banking application. Now, remember, account is object in object-oriented programming. So then we have to think about how these objects send messages, because this object has to communicate the other object and say, you do this. Maybe that object may call another object and say, please do this one for me. So likewise, that is how it happens in software, in object-oriented software. So that is where we have a type of diagrams called sequence diagrams. Right? Sequence diagram. How now, of course, the user interface is not an object, it's a human interacting. So then onwards, it is this object, this is sending a message to this guy, this object, it is sending a message to the other object, that is sending a message to another object. Likewise, so many object passing will happen. So we want to model that. We want to model that. So then only we can start developing the system. Okay, so that is why we have a designing phase. Right. Anyway, we will be discussing these in detail in your object-oriented SAD subject. Okay. So then we have another type of diagram called state diagrams. Because some of these classes will go through some state transitions. State transitions. Okay. So not every object actually, the major object, the major domain objects can go through the state transitions. Right? It's something like as humans, we go through the state transitions, right? So first we say it's an infant. Then we say it's a child. So then we say you are a youth. Then we say you are sort of a middle age, right, or adult. Right? So then we say you are in the old age. Right? That is state transitions. State transition. So similarly, if you take something like order, now forget about this. So this is also state transition, right? So then we have, say, order. So we can think of state transitions. Still the order has not confirmed. It's in the new state. It's a new order. Maybe now the order is confirmed and paid. Now we say that that order is in the paid state. Paid state. Still the goods are not dispatched. Right? Order is paid, say something like Singer or Avance. Still the goods are not dispatched to the customer, or it's not delivered to the customer. So once it is delivered, until it is delivered, it is in the paid state. So once it is delivered and you get the customer signature saying that, okay, we accepted the goods, then we can say something like dispatch. Okay. So maybe after sometimes, maybe after few days, if no complaints or nothing, the order will be closed. Order will be closed. Because you can't return the goods after, right? After 6 months, right? Unless there's a fault or something. If there are issues, you have to immediately return it. So there will be some period, right? You have to return it within 7 days or whatever. So therefore, after dispatch, it might again goes to another state, like the return. So likewise, there can be some possible, and also maybe after paid also, it can be cancelled. Order is cancelled for some reason. So we are interested in seeing these state transitions. What are the states? What are the transitions? Which kind of events are going to initiate transitions? So that is where we have state transition diagrams, right? So state diagrams, right? What are the states then a particular type of object can go through, and for which events are going to trigger those state transitions. So it's something like this. But this is not a very complete diagram. So this is just to give you some idea about, and you can see it can go from running to testing, right, etc., etc. Okay, collecting, blah blah. This is a very complicated diagram, right? So state transition diagrams are not that complicated. Okay, so that so there are so many simple state transition diagrams. If you do a search, state, say UML state diagram example, so you will find much more easy to understand state diagrams. Okay, sometimes we call them state machines also. So this is a state machine or state diagram for some sort of a device. So you can see off, self-test, right, idle, right, servicing the customer, right, out of service. So this is states that ATM machine, bank ATM, teller machine can go through, right? So teller machine is off. It is now doing some self-testing because it's a machine, computer. Right? Now it's idle, waiting for some customers. Now it is servicing the customer. Now it can go back to the idle. Right? Again, go back to the servicing. Again, go back to idle. Then maybe it can go to the maintenance mode. Right? You know that sometimes we have to change money. Right? So refill the money, etc. So while we are doing those things, others cannot interact with the system and withdraw money, and it can again go back to self-test and come back to the idle. So again, it's servicing the customer, right? And sometimes due to failures, it can go to, so maybe after, while it is serving also, it can go to the out of service. Maybe some error happened. Again, you have to do some maintenance and put it back to the ideal state. So when you draw it like this, right, you know that ATM machine is a very complicated device. So many things are happening. But once you abstract it like this, we abstract one particular concept called the state into a diagram. So that is the beauty of these diagrams, which take separate concerns into separate diagrams. How they are related, class diagram. How they pass messages to do a certain task, state, the sequence diagram. What kind of states they are in, possible states, and how they change one state to another state, or what are the possible state transitions, we have the state diagram. So we look at the same system and in a different way, so different point of views. So by collecting those things together, we will have a very good idea. Because if you try to draw one diagram and try to understand everything, right, it's not going to work. It's very complicated. But rather, if you draw several diagrams and you try to understand several different aspects separately, it's much easier. So that is how the engineers uh, tackle the complexity, right? So we have a very way of tackling the complexity, right? So that is state diagram, okay? Right. So this is pretty much a sort of a scaled down class diagram, okay? Unfortunately, they have not given class diagram, but I showed you how does a class diagram looks, okay? So it can have the association, inheritance, and composition, no aggregations, okay? Right. So now we are moving to the more advanced concepts. I told you now we have moved from the basics to the concepts. Of course, your note has not mentioned everything, but I mentioned separately abstraction, encapsulation, inheritance, and polymorphism as well. So now we are into the more advanced things, advanced object-oriented concepts. Okay, and so we'll take a break. After the break, we are going to continue with that part. Okay, right. So now we are moving to the advanced concepts, starting with the design patterns. Okay, so what is a design pattern? So this is how you understand design pattern. Design pattern. So there are some, when we are designing a solution, we will frequently encounter common situations or common problems, right? Common problems. So when you are developing a software, whether it's order processing system or inventory management or anything else, and so there are some common problems that we encounter that we need to solve. Okay, so then what the software developers has done is, because these are very recurring or common or recurring problems, they have given those common problems names, right? So they have named it so that we can identify that. We can discuss rather than explaining the problem, we can just use the name. Not only we name it, now the software developers has come up with solutions for this, and maybe one solution is better than the other one. So they name these common problems and they have documented the solution also. So when you have this kind of a problem, this is a possible solution. This is the best solution. Okay. And we call them design patterns, right? So we give it a name and we document the solution. So next time when we encounter the same problem, the software architect can just say, okay, so this problem we have to solve by using this design pattern. So that is the idea. Okay, that is the idea. And there are two types of design patterns. One is very high level patterns. We call them architectural pattern. And then we have more low level patterns. So we just call them the patterns. So this just the design patterns. Okay, these are architectural design patterns. These are just the design patterns. Okay. For example, MVC architecture. Right? It's an architectural design pattern. Whereas so many design patterns are there, like singleton pattern, factory pattern, adapter pattern, strategy pattern. Okay, so many patterns are there. So those are general patterns for low level things. Okay, right. So I hope you have the big idea. Right. So design pattern is a way of reusing abstract knowledge about problems and its solutions. So we identify the problem and a solution and we give it a name and we document the solution. Pattern is a description of the problem and the essence of its solutions. So description of the problem and essence. Essence means that, now you know what is the essence. When you are making cake, okay, or maybe some drinks, you can add essence. So that is the essential thing, right? Minimum required thing. So document the essential or the minimal solution. Okay. So that is what design pattern is all about. So it should be sufficiently abstract to be reused in different settings. So if it is abstract, we should be able to use it in different contexts, different situations. If it is not abstract or if it is not generic, we will not be able to reuse it. So in order to reuse it, we want to abstract it and identify the problem and the solution so that we can reuse it in similar situations. Okay. Right. Pattern descriptions usually make use of object-oriented characteristics such as inheritance and polymorphism. Yes. So when we document the solution or when we come up with the solution, we often use the concepts like inheritance and polymorphism to our advantage. Okay. Now you can't understand these terms, these concepts, unless if you have again semester 1 programming කරද්දී බොරු කරා නම්, right? බොරු කරා නම් දැන් ඔයාලට බොරුව chain reaction වෙනවා, right? So therefore those who know inheritance, those who know exactly what is polymorphism, those who have done some coding, right, to demonstrate inheritance, to demonstrate polymorphism, now you are in a better position to understand these advanced concepts. Okay, right. So patterns and pattern languages are ways to describe best practices or good designs and capture experiences in way that it is possible for others to reuse this experience. So that is why we document it. Right? So these issues we are going to face in the future also again and again. So once you know the design patterns, you know that, okay, this is the problem. So this problem can be solved using this. Rather than you think of solution, right? Rather than you think of solution, you the solution straight away comes to your mind. So you can say, okay, let's use the adapter pattern there. So this problem can be solved using the decorator pattern. Okay. Right. So you can see now when it comes to patterns, it's a documentation of a solution to a problem. So first we need to give it a name. So what is the name of the pattern? Okay. So I use some of these names like decorator patterns, adapter patterns, right? Observer pattern, factory pattern, singleton pattern. So those are the names. So each pattern has a name. Then the problem description. So what kind of a problem we can solve using this pattern? So then the solution description, or what is the solution? It is just, sometimes it's just a class diagram is good enough. Right? So experienced pro developer, experienced architect can understand the solution by just looking at the class diagram, or maybe just simple explanation together with the class diagram. Right? And the consequences, that means not every solution, a solution is not a perfect, right? Solution cannot be applied to all the places. A solution can have some drawbacks, some limitations. So we better, when we document the patterns, design patterns, they mention those as well. So this has this limitation. So there's a prerequisite for if you are applying this pattern, etc. Okay. Right. So they have given you just one example, I think, observer pattern. Right. Just one example. Okay. Right. Just one example as a just to demonstrate what is a design pattern is. Actually, design pattern is extremely interesting area. Right. So once you get used to these basic object-oriented concepts and has done bit of programming like swing programming, right? Bit of PHP, Java, right? Next thing that you will be really interested is learning these design patterns. Okay, if you are really interested in learning design patterns by yourself, there's a really good book. Remember, I recommended you the Head First Java for the Java programming and learning object-oriented concepts. Head First Java. It's a really good book, and it's about 20 years old now. Still, for me, that is the best book. That is the best book. Okay. I gave you the PDF version also in the Google Classroom. Right? Head First Java book, which is extremely interesting book. Okay, if you want to learn the Java language. Okay, together with programming, object-oriented concepts, etc. Okay, so these are not the traditional boring books. Lot of text. You know there are two type of books: the traditional boring books and the modern brain friendly books. So this is a modern brain friendly book. That is why we say head first series. Okay, right. So that is to get the basic idea about object oriented concepts and with the help of Java. Okay, so then if you want to go into the next level, the best book is head first design pattern. Right? Head first design patterns. But you will be able to understand that only if you have done a really serious work in your learning your Java, learning your programming subject. Okay. So let me open and show you. So those who are interested, okay, not for those who are just eyeing to get a certificate, degree certificate. Those who want to go into the field, industry, and do some serious stuff. Right. So this is a head first design pattern book. Okay. So it will explain you what is a design pattern, why do we need design patterns, and it will take few design patterns one by one, like a story, right? It will explain you how these design patterns can be used. Okay. And it will start with the strategy pattern and how to implement that also. Then it will explain some other design patterns like observer patterns, adapter patterns, uh, decorator patterns, etc. Not all the patterns. So there are about 14, 15 major patterns, but this will cover only about 6, 7 major patterns only. Okay. Right. So we can subdivide these patterns. These are not the architectural patterns, the base, the next level patterns. We can subdivide them into different categories as well, the structural patterns, behavioral patterns, etc. I will just mention you few patterns and very brief explanation. So the one of the popular pattern is uh, factory pattern, and there's a variation called abstract factory also. So we have to frequently create objects and create objects. So get an object or instance of class. Of course, we know that if you have a class called X, we can create object of X like X equal new X. Of course, that is possible, right? Say if you have account, you can say account, say A1 equal new account. But there are situations we have to create those objects in a different context. So then there's a concept called factory pattern. I'm not going to explain you the factory pattern. I'm just introducing you few patterns. Okay. So then there's another pattern called singleton pattern. So these are called creational patterns, right? Creational singleton pattern. So there are situations where we don't want to create multiple objects. Right? We don't want to create multiple objects to serve a client request. We want to make sure that we at any time you have only one object in the memory, and that object is serving all the requests. Okay, so that is called singleton pattern. So I'm not going to give you the details on exactly when to use it and how to develop it. Of course, the development is extremely simple, just 2-3 line of code, right? So that is called singleton pattern. Singleton pattern makes sure that at any time you have only one object of that class, and that object is serving you. Then someone will ask, why do you want to do like that? Right. So that is not what we are going to discuss here, because we are not going to do details about any of the patterns. Okay, so that is why I gave you the head first design pattern book, so that you can go through those and understand. You can't understand each and every pattern in a single day. Maybe you take one design pattern and you learn it for 1 week. Maybe take a break, another 2-3 weeks, right? So you can think something like, every month I am going to learn one design pattern. So don't be hurried. So maybe March I am going to learn the factory pattern. April I am going to learn singleton. May I am going to learn observe pattern. Right? June I am going to learn maybe something like strategy pattern, something like that. Okay, because you can't understand design patterns unless you have hands-on experience, hands-on software development experience. Okay, so that is why it's no point you to start learning design patterns unless you are now coding. So a very good time to start learning about design pattern is while you are doing your final year project. Maybe you can just learn 1 or 2 design pattern, but if you want to do some serious studying of design pattern, because while you are coding, you are developing certain things, only you can start learning advanced concept like design pattern. Okay, so I just mentioned you 2 patterns: factory pattern, singleton pattern. I'm just randomly giving you some pattern. Another one is adapter pattern. Right? It's a very interesting pattern. See, I have API or some software that I want to integrate with another one. Say this has exposed it as X way, but this is expecting it as Y way. But now Y and X is incompatible. Y and X is incompatible. Say I have a software, I want to integrate with this software, but it has exposed it in a different way than what I am expecting. So now there's a mismatch. Now I can't integrate. It's same as you have a square plug. You have a square shape plug, but you plug point. The point can. So it's something like this. Now there's a mismatch. So how do you do it? You come up with an adapter. Square now you're done. So that is what is meant by adapter. Similar thing you can do with software as well. Since we can't integrate these two, you can create an adapter utility class which expect this kind of things and expose it something like this. Okay. For example, in hardware also we do this. Say you have a monitor or maybe something like projector. Now the projector is, assume it's an old projector where I only take VGA cable, VGA input. Assume your laptop is a modern one, it doesn't have a VGA output, it has only HDMI output. Now your laptop has HDMI output, but your projector only accept VGA input. Now you're in trouble. Now you don't have to worry. You go to the hardware shop and you buy HDMI to VGA adapter. HDMI to VGA adapter. It will cost about maybe 3,000, 4,000. I don't know exact price because I have not bought it recently. So then you just plug it here, you are done. Now though you are having only HDMI, now you can send it to the your projector. Right? So you may have seen this, right? HDMI to VGA adapters, adapter cables. Hardware shop වල තියෙනවා හරි. ඒ ටික කරනවා නේද දැනගෙන ඉන්න බෑ. Something like this. Within the normal VGA, මේ HDMI, ඒතර අරයා ඉල්ලන්නේ මේක. මෙයා ඉල්ලන්නේ මේ. මෙයා කව තියෙන්නේ මේක. ඒතර ඔයා කියලා මේක ගහනවා ප්‍රොජෙක්ටර් එකට, මේක ගහනවා ලැප්ටොප් එකට. වැඩේ ඉවරයි. Right. So that is adapter. So similarly, we can create software units like this, so that we can integrate those incompatible things, softwares. Okay. So that is another example, right? So likewise, there are, so I just mentioned you 3 design patterns: factory pattern, singleton pattern, and adapter pattern. Another one is observer pattern, that is mentioned in your note, observer pattern. Okay. So observer pattern is something like this. Actually, observer pattern is heavily used in social media, right? Social media and like Facebook and also YouTube. So this is not rocket science. Right? Now remember, now assume, now we have a YouTube channel. Right? We have a YouTube channel. So we publish time to time. So time to time, maybe once a month or once in 2-3 weeks. So some of your lectures or some other things we randomly pick and publish it. Right? We randomly pick and publish it there publicly. So then, if someone is interested in our public videos, they have to subscribe. Otherwise, you may see it or you may not see it. Right? You may see it or you may not see it. So then we have software pattern called observer pattern, where if you are interested in something, you have to subscribe, or you have to subscribe to that queue. Then whenever this guy publish something, you will receive the notification, or you will receive it. And also you can subscribe to multiple message queues. So whenever something is published to these queues, you will be notified. So that is, so there must be a way to do these kind of functionalities. So that is a very common problem that we need to solve in software development. So software developers have identified this problem and give it a name called observer pattern. Right? So in this kind of situations are there, they have mentioned, okay, this is how we are going to develop this in object-oriented way. So that is all about observer pattern. Okay. Right. So you don't have to understand exactly how it is implemented, but you must just get a feeling of what is this observer pattern is, because at least observer pattern is mentioned in your syllabus directly. Okay, name observer, description, separate the display of object state from the object itself. So this is very specifically they have mentioned. So object is publishing and display means you receive it. Okay. Problem description used when multiple displays of the state are needed. Solution description in the next slide. Consequences, optimization to enhance display performance are impacted. So this is actually not the general observer pattern. This is adaptation of observer pattern for our weather station or something like that. Okay. So this is how it is implemented. You don't have to understand how it is implemented. That is beyond your syllabus. Okay. But the solution can be represented or presented in a way of a class diagram with few descriptions. Okay. Right. So that is just an example. So if you want to see in a much more serious manner, I highly recommend you to go through the head first design book. These are not at all boring books. These are very interesting books, extremely interesting books. It's something like you are reading a novel. Okay, something like reading a novel. You can see observe pattern, right? Meet the observe pattern. Right? You know how newspapers or magazine subscriptions work. A newspaper publisher goes into business and begin publishing newspapers. You subscribe to a particular publisher, and every time there's a new edition, it gets delivered to you. ඔයගොල්ලෝ මේක ටිකක් පරණ පොතක් අහන්න මේක මෙහෙම දාලා දිනනකොට මත ඔයගොල්ලෝ තමයි දන්නේ නැති වෙයි. ඉස්සර අපිට පුළුවන් ඔය මැගසින් වලට එහෙම ඉස්සර කියන්නේ මොකක්ද? ඒකට කියන්නේ මනි ඕඩර් එකක් යවන්න. හරි. මනි ඕඩර් එකක් යවන්න පුළුවන් අපිට කියන්න ඊළඟ මාස 6ට ඔය මුතුහර පරිගණක සංගරාව තියුණා. තාම තියෙනවා මම හිතන්නේ. ඒකට ඔය මනි ඕඩර් යවුවා මේගොල්ලන්ට. නැත්නම් අපි ගිහලා සැරින් සැරේ සංගරාව ගන්න එපා. ඒගොල්ලෝ මොකද කරන්නේ? සංගරාව පබ්ලිෂ් කරාම අපිට පෝස්ට් කරලා ඉවරයි. හැබැයි ඉතින් අපි මනි ඕඩර් යවලා සබ්ස්ක්‍රයිබ් කරලා තියෙනවා. සෝ ඉතින් ඒක තමයි එක්සැම්පල් එකට අරන් තියෙන්නේ. හරි. ඒ වගේ සිටුේෂන්ස් තමයි ඕකම තමයි දැන් අපි අර YouTube එකේ සබ්ස්ක්‍රයිබ් කරනවා කියන්නේ. නැත්නම් Facebook එකේ page එක follow කරනවා කියන්නේ. මේ කාලය වෙනස් නේද? කාලය වෙනස් වෙනකොට ලෝකෙ වෙනස් වෙනකොට ඒ concept වෙන විදිහකට ආයෙ එනවා. So therefore it's a recurring problem නේද? ඒ දවස්වලත් මේ ප්‍රශ්නේ තිබුණා. අදටත් ඒ problem එකට solution එකක් අපිට ඕන වෙනවා. දැන්. So you subscribe to a particular publisher, and every time there's a new edition, it gets delivered to you as long as you remain subscribed. Now you can see, so same concept. You subscribe when you don't want, you unsubscribe when you don't want to want paper anymore. So you can see that even YouTube, you have that unsubscribe option also. At any time you can unsubscribe. While the publisher remain in business, people, hotels, airlines, and other business constantly subscribe and unsubscribe to the newspaper. So if you subscribe, you will get the publishing, or if you unsubscribe, all of a sudden you are not going to get the future publications. Okay. Now, of course, I am not going to explain you the how to implement it, because that you need a little bit of more exposure, and you have to do it in your own slowly. Okay, slowly. Right. So I hope you have some idea about what is a design pattern. So here the idea is give you the idea about what is a design pattern. Here the idea is not to teach you a particular design pattern, just to give you feeling of it. Okay. Right. So now we are moving to the implementation. Remember, this topic is design and implementation. Okay. Right. So when we say implementation, what we mean is actually the development. Okay. The design is a model. We want to realize it. We want to make it a reality. We want to ultimately what we need is not class diagram or ER diagram. What we need is a database and software and the UI. Right. So when it comes to development, again we have to think about different things. Right. We want not only, we don't want just a software. We need software which does the work, right, which develop according to your design. And not only that, there are some non-functional requirements like reusability, maintainability, performance, okay, reliability, usability, etc. Okay. Reusability is extremely important, so that we can reuse our software or the software modules or software components over and over. So you will learn about these things in a very serious manner. In your semester 3, you have a subject called enterprise software development. So there you will learn how the software components, reusable software components are developed with the help of technologies like enterprise Java beans, the session beans, message driven beans, things like that. Okay. So reusability is extremely important. Right. So we can reuse at different levels, at the abstraction level, object level, component level, or we may even reuse the system as a whole. For example, we can expose our system as a set of web services so that the third party can use it. So we are reusing the system, or we are just reusing certain components only. Maybe we are just reusing the authentication or security component for another software. So that is fine. So why do you want to do the same thing over and over? Okay. So reusing is something that we have to make. It's a decision that we have to make in a very conscious manner, because there are some advantages, there are some disadvantages when you reuse. Of course, as much as we want to do the reusing, when you do reusing, that means we are going to reuse a component we develop for some other software. So what are the good things? What are the bad things? So the good thing is the moment you reuse, your effort is less, and that means your cost is less. You need less time. So we always want to develop software in a without wasting our time, right? Because the customers are really in need to get the competitive advantage. They need the software as fast as possible. So once you reuse, your time and effort is preserved, including the cost. Okay. And also these reusable components will be properly tested. Okay. You don't have to again test it. Right. So what are the drawbacks? What are the possible challenges we have? Number one is it may not fully fit, may not fully meet our expectation, fully meet the requirements, because this is not something we develop for this system. This is something we develop for another system. So that is very important. So that is the biggest challenge we have when we reuse. Okay. And sometimes these reusable components may also cost. Sometimes you might find that, okay, be developing that component is even cheaper than reusing. It depends. Okay. So therefore, there are all pros and cons when it comes to reusing. Right. Another aspect that we have to discuss or think about, when it, especially it's not only for development, this is applicable to entire software development life cycle, configuration management. Okay. So whenever you see the word configuration in IT, configuration means change. So therefore, in simple, this means change management. Okay. Change in software. We have to managing a change in software. So that is called configuration management. Okay. So it changed during the software development cycle. That is the develop analysis, design, development, testing, etc. As well as after the deployment, during the evolution phase also it may change. So what kind of things change? Almost everything. Right? So your requirements may change, your design artifacts and models may change, your software code may change, your test case may change. So in simple, anything can change. So configuration management means we want to manage these changes in requirement, the designs or models, code. That is called configuration management. Okay. So the configuration management includes some version management. So that means whenever you come up with a new or do a change to artifacts, it can be a design document, it can be a code. So if you use a proper repository like CVS, GitHub, whenever you check in a new version, whenever you check in, a new version will be created. Right? New version will be created. So therefore, at any time, we can revert back to the old versions and we can see the difference between this version and that version. So that is relevant for documents as well as your software or the code as well. Okay. Version controlling. Then the system integration. So whenever there's a change, we have to develop that and integrate into our main product. And also we have to track those changes, because sometimes we have to cost more, we have to reschedule our activities, etc. Okay. Right. This host targeted development is, it's not a big thing. So usually when we are developing a software, we are targeting a particular environment, right? Maybe we are interested in developing into a Java Enterprise Edition or .NET environment or maybe PHP environment. So depending on the targeted environment, we have to adapt certain technologies, practices, even code standards, etc. Okay. Right. So they have subdivided in some tools also, development tools, right? The compilers, debuggers, testing tools, right? Graphical editing tools like modeling tools, project management tools, right? All those things are possible. Yeah. Right. So they have mentioned another subtopic there, open source development. Okay. So when it comes to developing software, either you are developing open source software or you are developing a proprietary software. Mostly when it comes to general software development, we will be developing proprietary software. That is, we are not exposing the source code and we are not going to give it that freedom. Mostly what we develop is a proprietary software where the source code is only either your ownership or you just transfer the ownership exclusively to the customer. Okay. So therefore, when it comes to developing a software to a particular vendor, usually it is not an open source software development, it's a proprietary software development. That is, you look at whether it's open source or not by looking at the target or the customer need. Another way of looking at it is, do you use open source platforms or do you go for closed source? For example, if you use something like C#, .NET, so they are pretty much closed source software environment. But if you develop your software using technologies like Java, right, JBoss server, Apache Tomcat server, or PHP, so you are pretty much biased towards open source development because your technologies are open source. Maybe your product is closed source, but maybe your technologies are open source. Okay. So open source development is an approach to software development in which source code of the software system is published. So if you publish the source code with the customer or maybe to anyone, and usually for anyone, it's open source development. So mostly what we develop is not open source code. We develop something and we give that code only to the customer. We don't give it to anyone in the world, because then the customer is the one who is spending money, investing, right? Others will get the free benefit, and your customer is not going to get the competitive advantage. So competitive advantage is something you do which your competitors do not do. So therefore, your customer may not, definitely they are not going to like you exposing your source code to anyone. right? So there are so many open source softwares, environments, etc. Right? The Linux environment, operating system, and so many open source languages like C, C++, Python, JavaScript. MySQL database is also open source, whereas the proprietary things are pretty much Microsoft SQL, Oracle database, the technologies like ASP, so they are pretty much proprietary, not open source, okay, or closed source. And so some questions we have to ask. Should our product that is being developed make use of open source components? Are we using open source components in our development of the software? If we are using those things, we have to aware that we are using open source components. Or should an open source approach be used for the software development? Are we using open source components? Are we developing it? Are we developing open source software? Okay. And so if you comply with these concepts, either developing or the tools that you are using, etc., technology preferences, we call it open source business. So open source business is you develop your product, software, and you publish the source code to anyone interested. So you develop it and you publish the source code to anyone in the world. So then someone will ask, how do you make money out of that? So you make money out of that by making sure that your software is used by so many people and they need some extra support. So you are going to provide that extra support with some money, service fee. If you have very big client base, that is more than enough to survive and earn money. Okay. So that is how the open source business work. Okay. So very good example in Sri Lanka is WSO2. So WSO2 is open source business organization. You can see here also, right? WSO2 is an open source technology provider, right? You can see WSO2 is an open source technology provider founded in 2005. It offers an enterprise platform for integration, application programming interfaces, and web services locally and across the internet. So very clearly you can see that it's a open source business. Okay, open source business, and they are making a lot of profit out of that business. Though they don't have, you don't have to sell something to make money. You can give it free of charge and still make money. So very good example is Google. Google is giving you Gmail free of charge, YouTube free of charge, Google Map free of charge. Okay, Google Talk free of charge. Still, Google is one of the top businesses in the world. So they have a lot of wealth. They are making a lot of money, profit. So that is the beauty of open source business. Okay. Right. So in open source software, what we provide to the customer or client is open source license. Okay. So open source license are very liberal, but it doesn't mean that you can do whatever you want. So if you want to do whatever you want, you have to go for general public license, which gives absolutely no restriction over your source code. Okay. So there are different type of licensing models. Okay. Barclay licensing model, GNU lesser public. So we discuss all those things in your semester 1 when we were discussing the Linux, right? Free and open source software, especially the Linux. What are the different type of licenses? Okay. Anyway, they may not ask, but they may ask because it's mentioned in your slides. Okay. Right. So that's it about designing. Actually, it took more time than I expected. Okay. More time than I expected. Right. So now we have done topic 1 to topic 7. We have 2 more topics only. The software testing and software evolution. So those 2 topics we are going to do next day when we are doing software engineering, and we are going to finish it. Okay. Right. So again, we are going to stop a little bit early today. Right. So next time we will be doing these 2 topics and finish the software engineering subject. And also now we are going to start doing some past paper questions as well, because the maths topic is over. Software engineering, I need just 1 day. Database is almost over, but we have to do another topic. Two topics are there, but sometimes we may be able to do both the topics in the same day. Web we have a little bit more, so therefore I will be adding few extra classes, right? Maybe next week. But only thing is, it will be on a daytime. Okay, so those who cannot attend, you will be getting the recording, because we are in a very tight schedule. We have no other option. Okay, right. So we'll stop at this point. Right. Thank you.